episode of the World of Physics. Today in this session we are going to discuss about the classical mechanics. Okay, it's a new chapter, so it covers some basic important aspects that needs to be understood as a mechanical engineer. So these are the somewhat basics of the physics which must be the knowledge of which must be acquired as a part of mechanical engineering. So this is just a basics idea in which we are going to discuss about some geometries, that is circular, spherical geometry, cylindrical geometry and Cartesian geometry. Also we are going to discuss about the moment of inertia, that is mass moment of inertia, and some basic concepts about kinetics and kinematics. Okay, so let's first of all begin with kinetics and kinematics. So first of all, what is kinematics? Considering an object, consider a body on which the forces are applied, and because of that forces the body is performing certain kind of motion. Okay, let's consider this chalk as a body. On this body certain forces are there and this body is performing certain oscillatory motions. Okay, because of this motion, because of this force, the body is performing oscillatory motion. Okay, but while considering the kinematics as a branch of physics, we are just focusing on the motion of the body, not the cause of the motion. Means not considering the force that is causing the motion. The branch of that physics is known as the kinematics. So over here, as you can see the definition, kinematics is a subfield of physics developed in a classical mechanics that describes the motion of a point, body and a system of a body without considering the force that causes them to move. We are studying the motion but not the cause of the motion. Okay, so kinematics as a field of study is often referred to as the geometry of the motion. Means we are studying the motion, what path is following. Okay, it is performing the C-shape, seesaw type of motion. Means whatever the trajectory or path it is performing, we are studying that. We are studying the geometry about what fulcrum point it is moving, but not the cause that is causing the motion. Okay, we are just understanding the motion. Okay, so it is thus known as the geometry of motion. Kinematic problem begins by describing the geometry of the system and declaring the initial condition of an known values of the position, velocity and or the acceleration of a point within the system. Then using arguments from the geometry, the position, velocity and acceleration of an unknown part of the system can be determined. Means if we know some reference points, their values, then we can find the values for that unknown points from the geometry of the motion. Okay, so it is used to predict the motion at certain time interval. After certain time, what will be the type of motion? It is used for the prediction from the basic knowledge of velocity and acceleration. Okay, so that is nothing but a geometry. It understands the type of motion, okay, without considering the force that causes the motion. So that was all about kinematics. Further moving towards the kinematics, kinematics is also used in astrophysics to describe the motion of celestial bodies and the collection of such bodies in mechanical engineering, robotics and biomechanics. Kinematics is used to describe the motion of the system composed of joint parts, that is multiple link system such as an engine, robotic arm and or a human skeleton. Okay, so these are the branches where kinematics are used. Now let's move further towards the kinetics. So in physics and engineering, kinetics is a branch of classical mechanics that is concerned with the relationship between motion and its cause. Okay, and its cause, specifically the forces and the cause, torques. It does not only focus on the path or the motion, but also discuss or some look about the whatever the force that is causing the motion. Such a branch of physics is known as a kinetics. So since the mid 20th century, the term dynamics or analytical dynamics has largely suppressed kinetics in the physics textbooks. Means it is also known as a dynamics. Okay, kinematics. Kinetics is also known as a dynamics, but now in mechanical engineering we use kinetics as a word. Now let us discuss about the system of coordinates. Okay, so system of coordinates are mainly Cartesian system of coordinates, means x, y and z. If we talk about the room in which you are sitting, it's definitely a rectangular body. It has certain x value, certain y value and certain z value. So the system of coordinate is like that, x, y, z system. Such a kind of system is known as a Cartesian coordinate system. Okay, so x, y, z, wherever there is an x, y, z type of system, they are known as a Cartesian coordinate system. But if we think about this chalk, or let me give you just precise example. Consider this cylinder. So it has this z value. Now over here, as you can see, from the center the radius is there. Okay, so this is the radius, you can see over here. So the r value and the angle, means in order to describe this sector we need to define this angle. So this side of system has 3 dimensions, same as that of x, y, z in Cartesian coordinate system. But over here the dimensions are radius, angle and z axis or the axis. Okay, so such a kind of system is known as a cylindrical coordinate system. And the last one is the spherical coordinate system. Okay, means sphere is there, means radius is there. As long as the radius is there, the larger the radius, larger is the sphere. Angle in this direction is there and angle in this direction is there. So let us call this angle, one angle is theta and another angle is phi. So the system of coordinate is known as a r, theta and phi system. So here are the example of Cartesian coordinate system in which some quantity q is there. Let us talk is like this. If you can understand this, it is formed by 3-dimensional system: x-axis, as you can see over here, y-axis as you can see over here, and z-axis as you can see over here. Let us consider some quantity q is flowing over here. Let us call it as heat. Some water flow can be described as like this. So it is entering qx. After that, at the exit point, it will be x plus delta x. Similarly for y, entering is qy. At the exit point is y plus delta y. Similarly from the z direction, entering is qz and exit point is z plus delta z, as you can see over here. So this is nothing but a system of Cartesian coordinate system in which basically we are discussing the x, y and z directions. So what will be the volume of this system? That is nothing but L into B into H. So over here you can say it as dx into dy into dz. dx is the dimension, or delta x is the dimension in x, delta y is the dimension in y, and delta z is the dimension in z. So dx into dy into dz is the volume. Now let us focus on the cylindrical coordinate system. As I have told you, this is a cylindrical coordinate system. The part of a cylinder, certain part of cylinder, as you can see over here in the figure. So this is a cylindrical coordinate system. Certain part of cylinder is observed. Okay. So as you can see, one is the dr, radial element, dr radial, dz is the height, and this curvilinear part, that will be r into d theta. You can see over here that is r d theta. So while entering q from z direction, entering is qz, exit is qz plus dz. In a radial direction, it will be qr and exit is qr plus dr. In the theta direction, as you can see now, the theta direction, okay, so in the curvilinear part, this will be the theta direction. Okay, so theta plus d theta will be the output. So over here, as you can see, over here in this system, as you can see, the dimensions will be dr into r d theta into dz. So the volume will be dr into r d theta into dz. That will be the volume of the system. Okay. Similarly, the spherical coordinate system, in that we have already discussed that r, theta and phi will be there. So this is a part of sphere. Okay, this system you can see that is nothing but a part of sphere, in that this is the radius. So in engineering graphics we have also learned about the d phi and d theta. Angle with respect to HP, that is d theta. Angle with respect to VP, consider over here vertical plane. So this angle will be d phi. So we are focusing the same thing over here. You can see the d phi, d theta, whatever the angles are there. So angle with respect to HP is d theta and angle with respect to VP is d phi, and the radial direction, the combination of all three will result in a spherical coordinate system, r, theta and phi system, and in that we can just give the volume as r square dr sine theta d theta d phi. Okay, so that is how the system of coordinates are there. Now moving further towards the next topic, that is a rigid body and the concept of inertia. So what is a rigid body? Rigid body is an idealization of a body that does not deform or change the shape. It is an ideal body, and on application of a load it does not deform or change the shape. Okay? Formally, it is defined as a collection of a particle with the property that the distance between the particle remains unchanged during the course of the motion of the body. At a minute observation level, if you think that distance between the particle does not change and hence the shape of the body does not change, the distance between any two given point on a rigid body remains constant in the time regardless of an external forces or a moments that exerts on it. A rigid body is usually considered as a continuous distribution of a mass. One general real-time example of a rigid body is a ball bearing made of hardened steel is a good example of a rigid body. As you can see over here, there is an aeroplane drawn over here in the figure. It does not change, so it is considered its shape and size while pitching, yawing or rolling. Okay, you can see all these 6 degrees of freedoms. It can move in any direction. This direction will be pitching, this will be yawing, and this will be rolling. Okay, considering that. So one is rolling, one is pitching, and another one is yawing. So in all the direction it is free to move, but the shape and size does not change, hence it is considered as a rigid body. Now the last topic is the moment of inertia. A mass moment of inertia, that is I, is measured as an object's resistance to change in a rotational direction. Resistance to change in a rotational direction, that is known as a mass moment of inertia. The moment of inertia has the same relationship to the angular acceleration as mass has to the linear acceleration, that I is equals to mk square. Okay, where m is the mass and k is the radius of gyration. The moment of inertia may be expressed in the units of mass as the kg and radius is the meter square. So kg meter square is the SI unit of moment of inertia. Now the last topic is the angular momentum of a rigid body. So for a rigid body, the angular momentum L is the product of moment of inertia and the angular velocity. So L is considered to be I omega. Okay, where m k square omega can also be considered, and V is equals to nothing but R omega. V equals to omega is nothing but VR. So for the point on mass, angular momentum can be expressed as a product of linear momentum and the radius. L is equals to mvr. So this is the basics definition of angular momentum of rigid body. You just need to remember this equation and the definition only. Okay, that's enough for today, guys. Thanks for watching.